Okay, this is the video for lesson 4, definition of reflection and basic properties. So if you remember back in lesson 1 when we did this activity, you were asked to move the original figure here to each of the other positions so that it was an exact match. And if you remember, you could slide to get to one of those. So that would be a translation, and it would actually be a translation by a vector. And we even drew a couple vectors that would make that translation happen. But a simple translation won't work for these other two. And so we have different types of transformations that will work. So the second kind of transformation we're going to talk about is a reflection. And while translation requires a vector, a reflection requires a line of reflection. So we'll do an example before we get to this exercise. Okay, so here's an example of reflection. And in what I've drawn here, and you can draw a copy of this on your paper if you pause and want to catch up, or you can just watch. In this example, line L is going to be our line of reflection, and we're going to reflect points A and Q and P around line L. And so what I'm going to do in order to do this is I'm going to go ahead and copy them onto my transparency. And we'll make a copy of Q as well. Okay, and so in order to do a reflection, what we're going to do, it's also known as a flip. So we're just going to flip our paper over. Oh, I forgot something very important here. I want to also draw the line of reflection because then I can match it back up. So here's my line of reflection. Okay, otherwise I don't know where to put it. Okay, so I'm going to flip it over. The line of reflection stays put, and everything else reflects around it. So notice P, which was on this side, ended up on the other side of the line of reflection. A was here and moved over to the right, and Q didn't move at all. Q was a point on the line of reflection, and it stayed in the same location. Okay, so what I want to do now is to use my pencil and mark where those points are reflected points, and point A is right here. And so if I look at my original picture, this would be the image of P. We're going to use that same terminology. There's the image of P, and then this would be the image of A. So A prime and P prime show the transformed points on that. And then we could also call this Q prime, but it hasn't changed. Q prime is the same point as Q. Okay, so you might be noticing some patterns going on here. And another way to refer to this, we could call this reflection L, because it's reflected about the line L. And you can also think of this as like line L is like a mirror, and so this is the mirror image. And if you notice, the letters actually end up backwards when we do this, because what we're getting is the mirror image of whatever we had on the other side. Okay. Okay, now you can go ahead and complete exercises 1 and 2 that you have in your notes, and then we'll do them together. So go ahead and pause now and work on that. Okay, now that you've had a chance to work on that, Let me show you how I did it. Okay, so I've got my overhead sheet here. I'm going to trace my line of reflection first so I don't forget to do that. So there's my line of reflection L. And then let's trace our figures here. Okay, and I want to label the vertices of these because that's really going to be the important part of this translation, B, but I'll go ahead and draw the entire shape in and try to be as careful as you can. Okay, and then figure D over here. Notice this one has a curved line. It's a little different. There. Okay, so to do the translation, I'm going to flip it over and line up my line of, get my line of reflection and that point on there lined up. Okay, now this is going to be the tricky part. So, so here are my images, and I somehow have to try to transfer these onto my page. And so I'm going to mark the corners here first, and then draw the line, and then trace out the shape best I can. Okay, so it's not an exact match. I'm going to turn this one around so I can work on it. I'm going to trace, let's get the points there, and then I can connect the dots with my ruler. That might be the most accurate way to do this. Okay, so this would be A prime, C prime, and of course B prime, just like in our first example, is the same as point B, and then this would be the reflection of D, of figure D. Okay, all right, so and then in exercise 2, so these are our reflections. In exercise 2, it asks which figures were not moved to a new location on the plane under this transformation. Well, everything was moved under this transformation except for point B and then line L. The entire line L is in the same place. So those are the two things that were not moved. Here's an example of a reflection done for you. There's two figures here, and they're reflected about the line L in the middle. Notice that this figure looks like a T that's kind of pointing to the right is reflected, and the reflected image leans to the left. So just like what a mirror would do. And likewise with the arrow, the horizontal nature of it didn't change, but the direction that it's pointing did change. So when the arrow got flipped over, it changed from a right pointing arrow to a left pointing arrow. Okay. So sometimes reflections can be difficult to predict when they get a little more complicated. Okay, here's another example that shows you or demonstrates that you can have a line of reflection anywhere. It doesn't have to be a vertical line. Here's one that's a horizontal line, but you could even have a line of reflection that goes crosswise in any direction. It could be any line in the plane. So here's a horizontal one, and you can notice this little bit more complex shape here. Here's the original, and then here's the reflected shape, and then the line of reflection right here. And of course, P, here's a point on the line that did not move under the reflection. Okay, it's your turn to play again. So find exercise 3 and 4, and actually 5. I'll have you do exercises 3, 4, and 5 independently, and then come back and we'll do them together. For this exercise, you're going to need a protractor and a ruler. What we're going to be doing is reflecting these images and then measuring them after we reflect them. The problem you're going to have is it's difficult to get these reflections accurately drawn, so you might have a little margin of error. But go ahead and try it and come back and we'll do it together. Okay, once again, I'll have you watch me do this just in case you're still trying to get the hang of it. So here's our line of reflection, line L, or whatever it is. Yeah, it's L. We'll draw our figures in green. So there is my angle ABC. And I'll just go ahead and make the letters a little bigger so I can see it when I draw this. And then I have a circle here with a chord, if you remember that terminology, and then I think these are H and I. They're hard to read. I and H. Okay, so there's the figures that I'm working with here, and I'm going to, actually this is I and J. We'll call it what it is there. Okay, so I'm ready to reflect these images. I'm going to match up my line of reflection here, right how I had it. And then the tricky part here is going to be marking it on my sheet. So I'm going to lift up my transparency and just make the marks where those points are. Try to trace out the circle a little bit here. Yeah, kind of. Okay, and then, so if this gets a little messy for you, it's okay. Let me erase this. Okay. Okay. And then my angle. I'm going to mark my points. That's the main thing I need to know where they are. They're there and there. Helps if you just hold the transparency tight to the paper. I think I got those pretty good. Okay, so then I can lift this off and do a little connect the dots. So let's connect point I and J. This is actually I prime and J prime, right? J prime and I prime. And here's my angle. Okay, so the second part of this exercise says to measure the angles. This is supposed to be a 66-degree angle, so I can line up my protractor. And if you're rusty using a protractor, you might need to practice a little or get some help with that. So let's see. This angle goes from 0 up to 60. I might need to use the other side to get a little more accurate. Okay. From 0 to 60. It looks more like it's about, I'm going to extend it so I can use my protractor more efficiently. Okay. So I'm going to go ahead and use this. Let's see. All right, so it's between 60 and 70, but it looks like it's only about 64 degrees. So this is measuring 64 degrees. let me see what their angle measures here. Their angle measures, yeah, closer to 66. So it looks like when I copied this translation, I was just off by a couple degrees. So that's okay. Let's see if I can, we'll do this again. 66 degrees. So this one's 66 degrees. Okay, but that margin of error is due to the measure, the copying problems there. All right, let's see. Because they should be the same size, correct? That's what we're getting at here. So this is 1.5 centimeters here. This is about 1.5 centimeters there. It says 5 units. So this one should also be 5 units, whatever their units are. Okay, so when we use the protractor to measure the reflected ABC, let's label this. This is A prime. The vertex is B prime, and this point would be C prime. The measure of angle ABC was 66 degrees, and the measure of angle A prime, B prime, C prime was 64 degrees. Okay, almost equal. And if I'd drawn it perfectly, they would be perfectly equal. And we used a ruler to measure the length of image IJ after the reflection, and it's the same length. And the way we would do that, the length of segment IJ is equal to the length of segment I prime J prime. Actually for this we don't even need to do that. That is the notation for the length of the segment. Okay, so they're the same. So the point being is that they are equal. Okay, and then exercise 5 you were doing. We'll come back to the properties of reflections there in just a minute. So in exercise 5, this one got a little more complicated with that triangle that's on the line. And we have a horizontal line of reflection right here. And I've got this figure, triangle EFG. So there's E, no, that's F. E, F, and G. Got line L and figure R. And there's figure R. Okay, so when we translate this one, we're just again flipping over the line of reflection. Sometimes it helps to mark a point on the line of reflection so you can line that back up. We'll do that. Flip it over. Oh, I didn't mark it on my sheet. Okay, and there we go. We already had some points on that line of reflection. Okay, so let's mark our reflections on the paper. So I'll first mark this semicircle right there. Okay, got that one pretty good. And then I'm going to mark the vertices of this triangle. So there will be E prime, F prime, and G prime right there. So if we connect the dots, here's my reflected triangle. Okay, and they're overlapping each other. That's okay. E prime, F prime, G prime. Okay, so there's our reflected image. We have labeled the reflected image, and we reflected both of those. Let's label this one. Here's the reflected figure R. Okay. So let's go up and look at this basic properties of reflections now. We'll deal with the second half of it after the next example, but basic properties of reflections. A reflection maps a line to a line, a ray to a ray, segment to a segment, an angle to an angle. Reflection preserves the lengths of segments and the degrees of angles. So we measured that in example 4. We saw that the lengths of segments and the degrees of angles did not change. That's assuming that we did it perfectly. Okay. Okay, so a couple more examples to just flesh out a couple more of these properties of reflections, and then you'll be ready for your problem set. Okay, so I've drawn a line, L, a point on the line, A, and then a point over here off the line, point P. And I'm just going to quickly reflect this. Sometimes it's hard to draw a straight line. So there's my line, my point A, and point P. All right, and I'm going to reflect this and match that up. So over here I've got my point, my reflected point, and that's going to be P prime. And of course A prime is the same as point A. So there's my P prime. And I want to look at this because what we just read says that lengths of segments are preserved in a reflection. And we saw that in the example that we did. So I'm going to draw a segment right here. This segment crosses our line at point O. We're going to call this point O. So essentially it makes two segments. We've got OP right here, and we've got OP prime right here. So because length is preserved in a reflection, distance is preserved, we could say that for these segments, the lengths are equal. So the lengths of these segments are equal. Okay. Another thing is that P and P prime are directly opposite one another on this line L. And so this is a perpendicular segment here. So what we have is that the line, our line of reflection, is a perpendicular bisector of P prime P. Okay, line of reflection, I'll write this, is a perpendicular, and I can use that for perpendicular, bisector of this segment P prime P. So this line right here is cut right in half. And that's going to be important when you're doing these reflections. We're going to do some on the coordinate grid too. And just to know that that reflection is going to be the same distance directly opposite the line of reflection. Okay, here's another example for us to look at. Under translations, we looked at parallel lines and what happened to parallel lines on when they are translated, and we found out that translations map parallel lines to another set of parallel lines. So we're going to look at that right here too. So I've got a line of reflection drawn right here in the middle. Here's my line of reflection, M. And I've got line L1 that I'm going to reflect. And I've got L2. And I've drawn these so that they're parallel, L1 and L2. So L1 is parallel to L2. And I want to see what happens on reflection of those. Okay, so I'm going to flip my diagram over. And here's what the reflected lines look like. So I've got line, this would be line L1 prime, line L2 prime here, and I can draw them, my pencil, there's points. And so obviously, since we're flipping them over and we see that this is a mirror image, we can see that reflections are going to take parallel lines to a new set of parallel lines. So there's one, and there's two. So this would be L1 prime, the reflection of L1, and this would be L2 prime, or the reflection of L2. Okay, and we can make a case for that. We can make a proof for it, but I think for now, this will be good. We'll probably get back to that later. Okay, so what I'd like you to do now is look at exercises 6 through 9 and take a few minutes to do those on your own. Just go ahead and read it and answer the questions, and then we'll come back and correct those, and then you'll be done. All right, I have enlarged some of these letters because they are microscopic for my vision and maybe for many of you. I have posted an electronic copy of the notes so that you can put it on your computer and enlarge it so you can actually see it if you have trouble, if you ever have trouble seeing any of these diagrams. Okay, so we have, let's just start at this end and work our way. We're asked to label the unnamed points. So we've got H and F over here. So this must have been the original of figure A. Well, in fact, this says it's the reflection of figure A. So the point that corresponds to this point on the diagram is going to be directly across the line of reflection. So this is going to be H prime. And here's F. And if I follow it directly across the line of reflection, this would be F prime. Okay, so there's two unlabeled points. Now in this diagram, I'm not told which is the reflection, but I can tell because this is labeled J prime. So if this is J prime going across the line of reflection, that must have been J. And then I've got I, and I prime is labeled here. Okay, so that's all the unlabeled points there. And then we'll look up here. Angle ABC has been labeled. So we can label the reflections of each of those points A prime, straight across, B prime, and C prime. Okay, and that looks like number 6 is done then. We've labeled all the unnamed points. Okay, number 7 asks, what is the measure of JKI, of angle JKI? And if you remember, these angles are always named with the vertex in the middle. So JKI is right here, JKI. So it's this angle. So this is the reflected angle of, did we miss one here? Oh wait, I mislabeled something. Oh, if you were in class, you could have corrected me. Okay, this is I prime, K, and K prime. Sorry. Okay, you were just waiting to tell me about that one. So here's J prime, K prime, I prime, and its measure is 31 degrees. So that's got to be the same measure as this angle over here, JKI. So we can label this 31 degrees. and I could write it here. The measure of angle JKI is equal to 31 degrees. And now KIJ, this angle here is the same as its reflection here. So this would be 28 degrees. So the measure of angle KIJ is equal to 28 degrees. See how you can fix your errors as you go through a homework assignment. Okay, here we go. What else are we asked? Measure of angle ABC. So the measure of angle A prime, B prime, 6C prime is labeled 150 degrees. So it's the reflected angle. The distance is preserved and angles are preserved. So the measure of angle ABC is equal to 150 degrees. Okay, because reflections always preserve angle measures. So, sorry you couldn't see that. Measure of angle ABC is 150 degrees. Okay, so what is the length of segment reflection FH? So let's find FH, and that's right here. And we've got that reflected over here in F prime, H prime. And so that length of, and I'll just call it F prime, H prime, is equal to, that segment is going to be the same distance as over here. So it's got to be 4 units. And we've got another segment here. We've got IJ that's been labeled. IJ. Okay. I don't see it. I don't see the label on mine. Oh yeah, I do. Never mind. It's 7 right here. So I prime, J prime is 7. Therefore, IJ had to be 7. So the length of IJ is equal to 7 units. Okay. Wow, this is taking me a while. Okay. And here's one last question. What is the location of the reflection of D? Okay, so let's look here. So D is a point on the line. So the reflection, point D and its image are in the same place. So what is the location of the reflection of D? It is in the same location as D, as point D. And the reason for that is because any point on the line of reflection is going to be, its image is going to be the same as the original location. Those points don't move. Okay, so you can explain that in your own words there. Okay, so you have an exit ticket and a problem set to do, and I just want to review some of the if you look at your problem set, we will look at some of the things that we talked about in this lesson. So here's your problem set for lesson 4. A reflection is another type of basic rigid motion. And by basic rigid motion, what we mean is that all the lengths are preserved, the shapes are the same, lines map to lines, triangles map to triangles, rays to rays, segments to segments, and angles to angles. So reflections have the same basic properties as translations. When we were doing the slides, we saw that to be true, and the same is true with reflections. Even though there are definitely differences, They have those properties in common. They're distance preserving and angle preserving. Nothing grows or shrinks with this type of transformation. And reflections occur across lines. So in order to do a reflection, you have to be given a line called the line of reflection. If you don't have a line of reflection, you can't reflect. And this we saw in the one example. When point P is joined to its reflection P prime, the line of reflection bisects the segment P prime. So those are all things that are true. So use your transparency and go ahead and do the exit ticket and problem set, and be sure to have them corrected as you go. Don't try to do this without correcting your work as you go. Okay, see you around.